Hi, I'm Petri, CTO of WavKong. In recent years, Wi-Fi standards have evolved rapidly to support ever higher data rates. Currently, the latest Wi-Fi 7 routers support data rates of up to 40 gigabits per second, which sounds awesome, except that it isn't. Firstly, there are no internet connections for home users that could support such high data rates. And secondly, you can't use high-speed data further away from the Wi-Fi router. The reason for this is that every Wi-Fi router has a common bottleneck: power amplifier. Power amplifier is a component that's amplifying the signal before being sent out from the antenna, and it is needed to have any reasonable coverage for Wi-Fi. Without the amplifier, signal could be received only within a few meters from the router. The problem with power amplifier is that it's distorting the signal because it's not linear. Signal gets distorted the higher is the power. A common solution for this problem is to reduce the power for high-speed data until the signal is good enough. But this will also drastically reduce the coverage for high-speed data. Essentially, when you are having Wi-Fi 6 or 7 router, you can benefit of it only within the same room, if it's not a big room. In other parts of the house, you are basically using Wi-Fi 5 or less. Now, of course, there's a solution for this loss of high-speed data coverage. It's mesh. So you are adding boxes around the house to make Wi-Fi work properly. But that adds complexity, and not in a good way. It is difficult to configure to work optimally, and also the mesh itself is consuming half of the bandwidth for interconnections, so it's reducing the max available data speeds, and it adds lag. And if you are moving in the house, the signal gets interrupted when the connection gets switched from one mesh node to another. So instead of these workarounds, we wanted to solve the core problem, to linearize the non-linear power amplifier and get rid of the distortion that limits the usage of high-speed data. To be honest, the technology that we are based on, called digital predistortion, it's not our invention. There are thousands of academic papers about it, so it's basically common knowledge. But to implement it in a small size and make it work reliably is a completely different issue. We started 6 years ago developing a solution from scratch that included first studying the algorithm in simulations, then building a test platform using programmable logic hardware called FPGA, and further iterating the algorithms to optimize it to work with real hardware and real power amplifiers, until our method was mature enough to make it on ASIC. Now, here we are, using SOM that has our RPU chip in it. RPU stands for Radio Processing Unit because that's what it basically does, processing radio signals. It reduces the distortion caused by power amplifiers so that we can use high power for high-speed data. Our router currently supports only Wi-Fi 6, but we think that it's plenty enough for a normal user when you can actually use high speed in the whole house and not just in the same room with the router. And you don't need mesh. So in practice, how this affects a user is that if a conventional Wi-Fi router is just barely working in some area of your house, for example in a backyard, so that it's really frustrating to watch the rotating symbol all the time when you are browsing. With our router, you could browse and watch videos as fluently as in the same room with the router. So that's pretty much what I wanted to share with you about the technology behind our product. Thank you for watching.